write this heading, direction of flow of electrons and conventional current. Then you draw these two diagrams, these two only. Okay. Here electron flow from negative to positive, current flow positive to negative, conventional current flow. And throughout this course, conventional current is used. Therefore, always assume current flows out of the positive terminal of the source. So,
Sir.
never do this mistake. Always
Yes, sir.
current flow is from positive to negative throughout this course.
Sir. স্যার যখন আমরা নরমালি কোনো মানে সার্কিট ডায়াগ্রাম ড্র করি তখন কি আমরা কনভেনশনাল কারেন্ট নিয়ে অলওয়েজ কথা বলবো, নট ফর অনলি দিস চ্যাপ্টার, মানে যে কোনো সময়
for all the topics, for all the circuits, we will talk about conventional current flow. Okay, we will show the conventional current flow even when we are doing Fleming's left hand rule, right hand rule, everywhere conventional current. Yes, we are following conventional current flow. Okay.
Yes, sir. Sir, so every time we say the word current, that only means conventional current.
Yes, yes. From positive to negative, okay?
Yes,
Now
sir.
this circuit is done, right?
Yes, sir. Just the note is left.
Yeah. Now
No problem, sir. I will write it later.
Now oscilloscope, okay? Yeah, Abir, done, right? That one, previous one.
Yes, sir.
Okay, now oscilloscope. Oscilloscope is a device where we show the electrical signal in visual graph. You see in the diagram, we are seeing the graph. So electrical signal we are seeing in the graph, and from there we calculate the values. We can get from here voltage, we can get from here frequency also. Frequency, time period, all this can be measured. Okay, how this is working, we are going to understand from the structure. Can you write
Sir.
this? Yes.
Sir, it shows the graph of an electrical signal, but
Yeah.
what is that electrical signal?
You see, if we are giving sound in microphone.
Yes.
For example, we are giving sound in microphone. then this sound signal or sound energy is converted to electrical signal, right?
Yes.
And that signal we can get from the oscilloscope. We can measure the frequency of sound, we can measure the wavelength of the sound from there, and if you know frequency and wavelength, then you can find the speed of the sound, right?
Yes, sir.
By the formula V equals F lambda, right?
Yes, sir.
Is it clear? So this
Yes,
way
sir.
we are using the oscilloscope. This is only one example, but we can actually use this oscilloscope for many other purposes. Okay, many other signals. Okay, in our physics lab in university also we did the experiment with sound wave which was connected to oscilloscope.
Yes,
Okay,
sir.
now you see here oscilloscope. What is that? Uh, the oscilloscope is basically a graph displaying device. It draws a graph of an electrical signal. Uh, in most applications, the graph shows the how signals change over time. We have two axes. One is vertical axis, represents the voltage, and the horizontal axis is showing the time. So write this, huh? The one I underlined, that part you write. Okay, are you done?
No, sir. Little bit left.
Hmm.
Yes, sir. Done.
Okay, very good. Now, can you see the diagram?
Yes, sir.
It's clear now, right? The right side one, you see, we have already, you know about the heater cathode, right?
Yes, sir.
And here we are getting the anodes in different way. Look, anode is given this way here, right?
Yes, sir.
So that there is one hole here. This through this hole, the electron beams can go straight. These electrons are attracted by this anode, but they are going through this anode till to the screen. Here we have a screen of the oscilloscope, and on this screen we have some materials which are showing the flash of light. Some chemicals are there, fluorescent chemicals. If electron beams are flowing and falling on those chemicals, then we get flash of light as the graph. Is it clear?
Yes, sir.
Now it is controlled. This graph is controlled by these Y plates and X plates. That means electron flow. Electron flows, and they are deflected by positive. That means electric field, then magnetic field. They are deflected, right?
Yes, sir.
Isn't it? So these Y plates or X plates are working in that way. They are, uh, you know, helping the electron beams to fall in the right place according to the, uh, you know, time-based setting, according to the voltage setting.
Yes, sir.
Is it clear? And look here, Y plate is connected to the voltage per division, and X plate is connected to the time per divisions. Is it clear?
Yes,
So
sir.
here we need mostly these things. You have to draw now, but you don't draw everything. You draw only this part. What I am saying, only you draw this part. This tube you draw. Uh, Here you draw. Then you draw this X plate. X plate you draw, and Y plate you draw. These things you draw. The connection from X plate, you label them. X plate is connected to time base, and it is time per division, and Y plate is connected to voltage per divisions. Y amplifier, that is voltage per divisions. This way you draw and label.
Yes, sir.
Cathode, cathode heater, you know this. This is cathode and heater together, and this one is anode. Okay, this one also label anode.
Sir, can you explain the use of Y plates and X plates again?
Yeah, X plates and Y plates are used. You see here it's written time per divisions, right? And it's written here voltage per divisions, right? So according to the setting, they are applying force to the electrons, so that electrons can, you see here, uh, the voltage is shown by the y-axis, right? Already you wrote there,
Yes.
and the time is shown by the x-axis. So you can set your time and you can set your voltage, so that this graph can be smaller, it can be bigger, it can be amplitude more, amplitude less. This way it can affect the flow of electrons, right? Because the electron can go down, can go up, right? And accordingly, the shape of the graph is coming, isn't it?
Yes, sir.
So this way X plate and Y plate is affecting the path of electrons, okay, by the by the settings. You see the settings is there, right? We can change the knob to get the settings.
Yes, sir. Finish that.
So done, drawing is done.
Yes, sir.
Okay, so if you are done with this drawing, yeah, Karim, are you done with drawing? Karim, Karim is not there. Oh, then yeah, what can oscilloscope measure? You write this heading.
Yes, sir. Ready.
Yeah, what can oscilloscope measure? You can write this. Other than measuring voltage at time, many scopes have measurement tools which help to quickly quantify frequency, amplitude, and other waveform characteristics.
Yes, sir. Finish it.
Okay, you finished writing. Very good. So this one, you know, what is the definition of frequency and time period and how to get it right.
Yes.
Okay. Then we have resistor color code, right? Measuring resistance using color code. Measuring resistance of resistors using color code. Write this. You wrote?
Yes.
Okay, then you write this heading. Calculating resistor values.
So heading calculating
Yes,
resistor value.
yeah. Calculating resistor values. Look, here we have some resistors which have 4 color bands, right? 4,
Yes.
which have here 5 color bands, which you see 6 color bands. But normally in our lab we get 3 color bands. Okay,
Yes.
how many?
2 or 3.
3 color bands, 3. And 3 color bands we get, and there is 4th color band that is not for measuring the resistance, that is for measuring the errors or tolerance. Okay, so we will focus only the 3 color bands. Okay, three color bands we will focus. Is it clear?
Yes, sir.
Now,
Which three color bands?
yeah, these three, the middle three.
Oh,
Okay, so from these three color bands, we can calculate the resistance of a resistor. Now, look here, we have one example here. Like here is given the table, right? Look here,
yes.
black is 0, brown is 1, red is 2, orange 3, yellow 4. This way, the values for the colors are given. Values for the colors are given. Now, in your exam or in your test, we will not give you pen. We are not giving you pen to memorize all these color numbers,
Color
right?
to
Like
memorize.
you do not need to memorize. They will give you.
Oh,
Okay,
okay, sir.
for the colors they are testing, for those colors they will give you the number. Okay, and they will tell you which one is band 1, which one is band 2, and which one is band 3. Okay, so yellow
Yes.
is band 1 here, violet is band 2 here, and red is here band 3, color band 3. Okay, now for yellow they are giving yellow is 4, then violet is 7, and red is 2. Till here they will give you. Okay, where till here they will give you. Now what you
Yes.
have to do from this value, they will they are giving you this 472. Now what you have to do, you have to write for this 4 here 4. Okay, first one you wrote. Then for the second one again you write here 7, and for the third one is your work. What you have to do, this third one is the power of 10.
Yes.
Okay, 10 square, and it's coming 47 multiplied by 100, 4700 ohms. Is it clear?
Yes, sir.
This way you have to calculate only. Is it clear?
Yes, sir.
So you write here, for example, a resistor has the following colored markings: yellow, violet, and red. 472. Then you come till here. Okay, come till here.
Yes, sir. Done right.
Mhm. Done. Eh?
Yes.
So our color code is almost done. We have little bit left. And you write the heading tolerance.
Tolerance.
Yeah, tolerance.
Yes, sir. I wrote.
Then after writing tolerance, you write the fourth band is other than using other than writing R, you use is here. Right?
Yes.
The fourth band is used to determine the percentage tolerance of the resistor. The Resistor tolerance is a measure of the resistor's variation from a specified resistive value and is a consequence of the manufacturing process and is expressed as a percentage. Is it clear? So it is the problem with manufacturing. There might be some errors or some contaminations, okay, some limitations, and because of that we have these errors, which one we are naming as tolerance. Okay,
Yes.
okay, then you write most of the 4-band resistors have tolerances 5%, 10%, and 20%. Okay,
Yes.
and color code used to denote tolerance rating of a resistor given as brown 1%, red 2%, gold 5%, silver 10%. Okay. Normally, in our lab, we get these two, gold or silver. Okay,
Yes.
not the brown or red one. The 4th band we get either gold or silver. Okay,
Yes.
so you write only these two. This one we don't need, brown red. Then you write here, if resistor has no 4th tolerance band, then the default tolerance would be 20%.
Sir, in exam we have to find the tolerance.
No, this is only for your knowledge. In exam, you will get only that part you wrote before. Okay,
Oh,
for the example you got that one. Is it clear?
yes, sir.
Yes, it is for your knowledge. Okay, that you will see in your lab sometimes the resistors. Then you might have interest that what does it mean. Is
Yes.
it clear? So we are done till this color code, right?
Yes.
Hello.
Hello, sir.
Yes. What happened?
Sir, transformer boom.
Transformer. Okay, I understand now. In your area, right?
Yes, sir.
Okay.